Video 2 of the spring break assignment is dealing with an introduction to electric current. And again, we're going to continue drawing an analogy between electricity and things that we already kind of have some intuition about. So when I hear the word current, I think primarily of rivers. And in rivers, when we're discussing current, and this is just going to be me awkwardly combing through a couple of rivers. Ooh, nice. Good river. It's a nice river. Yeah. Okay. When we, oops, I went too far. But when we're talking about the flow of currents within a river, what we're really talking about is how much water is passing a certain point in a certain amount of time. Or in a river, we're talking about how fast the water is going. We're talking about how much water is passing a certain point in a certain amount of time, and water is what's flowing through the river. In an electrical circuit, we're not talking about water flowing through the river, or water flowing through the circuit, but we're talking about electrons flowing through the circuit. Electrons are free to move in a conductor, and the electrons are what's actually flowing around our electrical circuit. So in a river, if we're discussing current, we might be talking about how much water is passing a certain point in a certain amount of time. In an electrical circuit, if we're talking about current, we're talking about how much charge is passing a certain point in a certain amount of time. In terms of the equation for electrical current, the symbol I represents current. The symbol delta Q represents how much charge. It's delta Q because it's the change in charge, or how much charge passes a certain point at a certain time. Represents the amount of charge that's passing a certain point. And T represents the amount of time passing a certain point, or how much time it takes that charge to pass a certain point in a certain amount of time. So current is equal to the flow of charge over time, or the rate of flow of charge. In terms of units, the unit for current is the capital letter A, which stands for amperes, or amps, as it's commonly called. Charge, the unit for that is the capital letter C, the coulomb, and time is measured in the unit of seconds. What that means, though, for Q, and you're going to see a theme here throughout, for Q is in the unit of coulombs. So if you're given the unit for electric charge in elementary charges, you always have to convert to, oops, what just happened? You always have to convert to coulombs. So that's going to be a theme throughout all of our electricity equations. Since an amp is defined as a coulomb per second, you always need to convert elementary charges to coulombs before using this and any other electricity equation. At this point, you try out those sample problems as well as the circuit drawing problems on the back. You can check your answers with mine, and when you're good, move on to the next video.